With the new i1 Pro 3 Plus device, the ability to profile transparent and translucent materials like backlit signage and textiles has been added to the i1Profiler software. In this module, we will focus on the use of i1Profiler software for creating transmissive profiles. We also have a video in the i1 Pro 3 for Photo e-learning course, which provides a demo of the hardware. If this process is of interest to you, we would certainly suggest that you also view this course. Transmissive profiling is available for RGB and CMYK driven printing systems and requires the i1 Pro 3 Plus with a photo license for RGB or publish for both RGB and CMYK on either your i1 Pro 3 device or dongle. Since the release of i1Profiler version 3.3, transmissive profiling has also been supported when using an i1-IO3 table with an i1 Pro 3 Plus device for measurement automation. To perform the transmissive measurements with either an i1 Pro 3 Plus alone or with an i1-IO3 table, a light box is required. There are a lot of light boxes available in the market which may be used. Preferred light boxes would have a color temperature range from around 5,000 to 7,000 Kelvin with consistent lighting across the entire measurement area. Higher color temperatures would work as well, but a color temperature in the natural daylight range is typically best. The higher the brightness level of your light box, the faster the measurements will happen. A4 or A3 formats work well, and when using it with an i1-IO3 table, the thickness would ideally be below 10 millimeters. However, thicker light boxes may be used if you raise the measurement arm on your i1-IO3 table using a Z-axis spacer. One spacer provides an additional 23 millimeters, which means you could use a light box with a thickness of 33 millimeters. If necessary, you may also stack two spacers, providing sufficient clearance for a light box up to 56 millimeters in thickness. For use with an i1-IO3 table, you should avoid light boxes with raised frames. This is because the i1-IO arm needs to glide smoothly over the entire light box. Because the properties of the light box will influence the measurement of the test charts, the transmissive profiling workflow includes a step for measuring the light box itself. This allows the i1Profiler software to compensate for any inconsistencies should this be necessary. The light box used for chart measurement is not required to have the same light properties as the viewing backlight for the final product. This is because the profiling workflow includes an optional step to measure the final viewing light if that is possible. If not, this step may be skipped. The transmissive profiling workflow, when using an i1 Pro 3 Plus device for handheld measurement, differs from the workflow when using an i1 Pro 3 Plus device with an i1-IO3 table. For this reason, i1Profiler offers two separate workflow choices from the home screen. The workflow, when using the i1-IO3 table, not only automates the measurement process, but there is also a difference in the test chart creation. When building transmissive profiles with an i1 Pro 3 Plus in handheld mode, an iterative chart generation process is used. The first chart, which contains approximately 100 patches, is printed and measured. Based on the measurements of this first chart, a second chart with roughly another 100 patches will be dynamically generated, printed, and measured. This iterative approach allows you to build a profile with the minimum number of patches. This is done to save time, as the measurement of transmissive patches requires a longer time than does reflective patch measurement. The workflow when using an i1-IO3 Plus table uses a classic test chart generation process with the ability to define a custom number of patches from 280 to 6,000. Because measurement is automated, the higher number of color patches is not an issue. Measurement time is still longer because the i1-io3 is reading in spot mode to get the highest measurement accuracy, but this automation frees the operator for other tasks. Whatever transmissive profiling workflow you choose, the software guides you through all necessary steps. Let's take a quick look at transmissive profiling with an i1Pro3 Plus for a CMYK printing system. From the i1Profiler home screen, we select CMYK printer and then transmissive profiling with i1Pro3 Plus. The first step, Test Chart 1, guides you to create, save, and print your first test chart as well as a lightbox template. You then define your print media type, clear, translucent, or textile, and the desired print paper size, which of course depends on the size of your available measurement lightbox. You then save and print the charts without any applied color conversions. The next step, Lightbox, guides you to measure the lightbox itself. This includes a spot measurement of the lightbox turned off and then another with it turned on. This provides i1Profiler with information about light diffusion of the surface. You are then prompted to scan the lightbox. This provides i1Profiler with information about the homogeneity of the lightbox output. For this step, the printed lightbox template is used. The template is taped to the lightbox to frame the measurement area. You will need to measure very slowly to complete the measurements successfully. The completed measurements can be saved as an asset for later reuse. This saves time as the lightbox does not need to be remeasured when building future transmissive profiles. The next step is to measure the first profiling patch set. Depending on the type of media, clear, translucent, or textile, this includes a spot measurement of the material on an opaque surface. After this, it will be mounted to the lightbox so that it fits to the lightbox template to measure on the same area, which was scanned without any chart. After the measurement is finished and saved to the Assets section for possible reuse, the next step is to define the desired profile settings. In the case of a transmissive CMYK profile, the black generation and separation rules are defined. Going to the next step, Test Chart 2, you will generate, save, and print a second test chart. This second set of color patches is dynamically calculated based on the measurements of the first chart. Click on Calculate Patch Set, then Save, and print this target. Be sure to use the exact same print settings as used for the first test chart. We will then measure the second test chart, mounting it to the lightbox, just as we have done before. In the final step, Viewing Lightbox, it is possible to measure the properties of the final viewing light, which is used to present the final printed product. Often, accessing this final viewing light is not possible. This step may be skipped by choosing the option Same as Measurement Lightbox. The final steps are to define the ambient viewing light, save the profile, view the results, and to compare the profile to others as introduced in previous modules. Creation of transmissive RGB printer profiles is very similar. The only difference is that the black generation and separation options will not be there.